Hey Precalc, we're going to move on to Chapter 2, Section 2, and we are talking about polynomial functions of a higher degree. So this is the x to the third, x to the fourth, and the essential question is, can you sketch graphs and find zeros of polynomial functions? The first thing we're going to do is look at graphs of polynomial functions. So let's start here. Polynomial functions have continuous graphs, which means you don't have to pick up your pencil to draw them. Functions with graphs that are not continuous are not polynomial functions. Here, this is a piecewise function. I do have to pick up my pencil. Polynomial functions have graphs with smooth, rounded turns. So as you can see, this one is smooth and rounded. And the last says functions with graphs that have sharp turns, like an absolute value, are not polynomial functions. So how do I sketch the graph of f of x is equal to x plus 5 to the fourth power? Yes, a lot of times you guys just say, let's put it in a calculator. But what's another way that I can graph it? We can always use an XY chart and plug in numbers. I'm hoping you have some sort of knowledge of what this is going to look like. This is to the fourth power, but let's go ahead and start plugging in numbers. Let's plug in numbers smaller than 0 and larger than 0. In my guess, I would think that because it is plus 5, it is going to go to the left 5, but let's see. Oh, you know what? Let's see by plugging in negative 5. If I plug in negative 5 plus 5 is 0. So that is one of our points where x is negative 5 and y is 0. What happens if I plug in negative 2? Negative 2 plus 5 is 3. 3 to the fourth power, well, 3 to the fourth power is 81. That's really high. I'm not going to graph that. So actually, these numbers that I came up with are pretty poor. Let's go around from this negative 5. What if I plug in negative 4? Negative 4 plus 5 is 1. 1 to the fourth power is 1. What if I go to negative 6? Negative 6 plus 5 is negative 1. To the fourth power is also 1. So I know that here and here, I am going up. And what about if I plug in negative 3? Negative 3 plus 5 is 2. 2 to the fourth power is 16. So at negative 7 and negative 3, we're going all the way up to 16. Now, I'm going to graph that way up here. I don't know where that is. That's way up. So notice this one has a little bit of a different stretch. But one thing I want you guys to notice, go ahead and throw this in your TI. If you notice, this one, I call it the U because it looks like the University of Miami, where it makes a little bit of a, it's not constant, but it just goes up by a hair. So if I was to plug in all these numbers in between negative 5 and negative 6 and negative 5 and negative 4, you would have all these numbers where it kind of flattens it out right here. So go ahead and throw that in your TI real quick. When you plug it in your TI, you might have to zoom in a little bit. So zoom in, see what you got there. All right, so this one's a little bit harder to see. I'm doing it right along with you, but if you notice, it's a little bit harder to see. But anything to the fourth power kind of has that flatter, it doesn't look quite like a parabola. All right, great job. Moving on to the leading coefficient test. I do see this in places, so you might want to take notice. Notice the first thing is if the exponent is odd. So this is saying if it's odd. Think about a cubic. A cubic goes down to the left and up to the right. That is if a is greater than 0. If a is less than 0, a negative cubic, it goes up to the left and down to the right. Again, this is assuming that you know your parent functions. What about if it's even? What if it's an even function? Think about an x squared. An x squared, if it is greater than 0, a is greater than 0, meaning it's like 2x squared. It is going to go up to the left and up to the right. And if we have an even one where it has a negative, it is less than 0. I keep doing that, sorry. it is going to go down to the left and down to the right. So the leading coefficient test just tells us odd numbers are going to be different. One's going to go up, one's going to go down. So they're talking about what the graph looks like. So let me put it into terms. If I have x cubed, you know the parent function to x cubed looks like that. Now, if it's negative, if I have a negative x cubed, you know that an x cubed function negative is going to be flipped. So I always like to go back to odd being cubed and even being x squared. You guys know what an x squared looks like. It's a parabola. But if it's a negative number or a negative x squared, it's going to be an upside down parabola. So these are things you know, but now we have just a different name. It's called the leading coefficient test, and you will see questions regarding the leading coefficient test. Zeros. There's a bunch of things we know about zeros. Zeros are solutions or roots or x-intercepts. So there are a bunch of names for zeros. The first thing we need to know is if x is equal to a, it is a zero of the function. This is just saying it is an x-intercept. If x is equal to a, it is a solution. So remember, we call them zeros, solutions, roots. They're all the same thing. They also tell us that x minus a is a factor of the polynomial. A factor. And we also know that a0 is an x-intercept of the graph. So let's talk about something that we did in Algebra 2. We did this all the time in Algebra 2. If I had x squared plus 7x plus 10 is equal to 0, remember that we can factor this to be x plus 2, x plus 5, and we called these factors. We factored it, and that's what the above is saying. And then when we solve, we said, oh yeah, x is equal to negative 2 and negative 5, and these we called solutions, zeros, roots, and it's also telling us that these can be the x-intercepts. Now, there are many, many, many ways we can find zeros. This one you know how to do. We can just factor. So I know I'm finding zeros if it is equal to 0. And here I can factor out an x. And I have x squared minus 12x plus 36, which can continue to factor, which is x minus 6 quantity squared. So my zeros, these are the factors, x, x minus 6, and x minus 6. The zero solutions are roots. Remember, we make them each equal to 0, so x is equal to 0. And we have two of these, x minus 6 is equal to 0, so x is equal to 6. Now, they call this multiplicity, okay? We used to call it double root, not two root, we used to call it a double root. The book now calls it multiplicity, so just be aware of that. All right, the last one, we're going to go ahead and put this in our TI. I'm just going to remind you, I can't show you my TI while I'm using Explain Everything, but I just want to remind you in your TI, once you graph it, so once you graph it, you can hit second, which is the blue button, and then hit calc, which is the top gray button that's over trace. And from there, I think it's at number 2, there are zeros. So you can find all your zeros in a TI, and that's what it's actually asking you to do, is to find all your zeros in a TI-84. So why don't you guys try that? If you don't know how to do that, go ahead and Google how to find zeros in a TI-84. Great job.